Record. Okay. We'll give you the intro from the other class. Okay. We have here. I have prepared some slides. Oh yeah. Let's do. First of all, let's. I quickly want to walk you through the module. So I have spent quite some time to organize this entire course into modules. So you will get with each module we're having, you will get one of these modules going online. It goes online the evening before, so you can prepare and download all the files, look at what we're gonna do. And this will contain always the same thing. So it's kind of learning objectives, gives you an overview of what is being discussed in that class. It gives you the Zoom link, your main lecture, but you also find it in the Zoom tab. It gives you here essentially an overview of the files that we will be working with. It will contain a lecture file. It will contain, in most cases, an Excel spreadsheet. It will contain, in some cases, an PowerPoint. So I don't know how comfortable you are with file system, with a file system. Mac or in Windows. Everything after the period indicates what type of file it is. So .r is R code. .xlsx is an Excel file. .docx is a Word document. PDF is a PDF. Which I won't have that many. Mainly I post the actual PowerPoints, for the reason that you then can make notes and you can annotate the PowerPoints, whatever I said or whatever you want to correct. So everybody has a different organization system. So this part is then followed by external resources. So these are, if something is in this page, there's additional information contained that may be interesting for you to study in addition to what we discussed in class and to what is being discussed in the book. Please read the respective chapters for each topic, just to make sure that all the material is understood. I will try to cover everything that will be on the quizzes and exams. I try to not leave anything out. But it's a very broad topic in many cases. So if there's something I don't touch on in class, make sure that you have read the book and seen what which may have lacked. Good. Discussion topics. We've talked about those. Low-hanging fruit, 50 points, 10 discussion topics, hopefully interesting videos. Comment on the videos, make a reasonable statement, reasonable comment. Either I ask for one. If I don't ask for one, just give me a general thought. Give me a general opinion, any thought you have on that topic. Be creative. I'm looking forward to your thought. I want to understand who you are, where you're going. That's why I ask for the virtual introductions. And I want to understand your thought process when you're exposed to something from statistics. So it's interesting for me. I actually enjoy reading those. Good. Discussion topics, 10. You will find them in your module. Comment on them when you see one. There will be 10 in total, numbered from 1 to 10. Practice quiz. The practice quiz actually will allow for you to prepare for quizzes and finals and midterms. It's topic specific. All these practice quizzes basically handle the respective topics they're stating in the header. Additional readings, additional supplements. Virtual office hour is basically by appointment, or we can happily get on a call. I'm all game. Whatever helps you to get a better grasp, I will happily support you. Good. All right. So first thing I would like for you to do. First thing I would like for you to do, please open your Finder or the Windows Explorer for those on a Windows computer, and make a right click or Control and left click. For those on Windows, basically Windows Explorer, go on desktop and create a folder on the desktop. When it opens a folder, it's new folder on Windows or it's untitled folder in Finder. Call this folder STAT1021. STAT1021 is fine. Once you have that, please go inside of the folder and create now an additional folder, which you call module 1. And save all the files that are part of module 1 in the module 1. Then create a module 2 folder. Yes. Yes, I give my best. I'll keep it in mind. Please call me out if it goes softer again. I have a tendency to get softer when I speak. Module 1.
That's inside of STAT?
Inside of STAT1021. Yes. You can also call it class 1 or be creative. It's not anything I want to mandate or dictate. It's just the reason why I'm saying it, because we're going to be dealing with 26 different modules. And it becomes complicated because it's a lot of modules. And I think there's some benefit that you have the syllabus that gives you the module number and you find each respective topic organized in your folder. Because you get 26 multiplied by 3 to 4 to 5 files. This becomes a lot of files. And if you have 100 files just unorganized somewhere in a folder, it becomes a little messy. But it's in essence, it's up to you. I suggest you use this form. So just to give you a taste of how this is going to look like in the end, we're looking here at something like this. So this becomes a lot of folders, and each of these folders contains then files and subfolders. So it becomes a little complicated. We create our own files, we're downloading files. So it's just make sure you follow up, and you follow along with some structure that is easy to comprehend. Because just keep in mind, it's open books. You can use your own notes, and it's in your interest to find your stuff quickly. So it's just I have taught this class a couple of times, and I have just seen where the areas of improvement are. So I'm just trying to help your future self. So that's kind of the idea. Okay, good. Good. So now in this STAT1021 folder, we have now in module 1 3 files that are to be downloaded today. The first one is an Excel file, which we're going to talk about in a few minutes. Then we have an R code, which hopefully we're going to get to. And then we have a PDF. And we're going to talk about the PDF first. Are there any questions concerning the outline, the folder making? I hope it was kind of comprehensible. If any questions, let me know. You can always email me. It's my preferred mode of communication. I will try to be very responsive. They usually come back to you within 24 hours. If I don't, please follow up with me. I have 6 different email inboxes. Sometimes something falls through the cracks. Don't take it personal, just follow up with me and step on my toes. Not literally. Okay, so we have now the PDF. The PDF are the first slides that I want to show you. To some extent, we're going to talk about this again on Wednesday. Just want to give this a first look at the topic. So we talked about what statistics are, what research is. Research in the greater realm basically means to find insights on a smaller sample of a population, tries to extrapolate this and generalize this to a larger population. And this is where the discussion starts. Why are statistics being used? I think this is just a super nice slide. Please have a look at the link. It's actually very nice when it goes through the history of statistics, because statistics has been around from earliest times, and it basically has shaped in the use cases over the history of time for different reasons. What the use case was of this time has basically shaped what researchers were interested in or what mathematicians and researchers. So you have Egypt, from ancient Greece to the UK. Robert Thomas Bayes was actually a mathematician that defined Bayes' theorem, which is the underlying principles of conditional probability used to this day, and still very central and important to this day. And various other examples up until the point where we are now, where we are basically looking at so much data and making sense of data has never been more important than it is now. Because nowadays, everything around you is data. Every device that you own will collect data. Not every. 90% of all devices nowadays collect data. That is true for a smart scale or a digital scale that synchronizes with a phone app. This data will be utilized in some shape or form for population statistics. If you open up, so I should step away from using brand names, but there are online resellers that sell enormous amounts of content. They do predictive analytics, what you will buy. They will not only do predictive analytics, what you will buy and will suggest it to you, they will also fill their warehouses based on what they're predicting you will buy in a week from now. So all the logistics are basically based on statistical algorithms, which are basically artificial intelligence and machine learning algorithms that are predicting the future and minimizing their efforts and streamlining their costs. And this is just, we live in interesting new days, and so it's interesting to basically go through the history of statistics to see how it has changed over the years. And essentially, if you're interested in going further in R as a software is a software that's actually perfectly suitable for artificial intelligence and machine learning algorithms. So these sophisticated, advanced analytics that are nowadays being used for various use cases are basically done with softwares like R or Python. So this is really a reflection of how I look at this class. I want you to basically understand how to employ these methods and how can they be utilized. But firstly, let's start with some definitions. So we've talked about populations. Population is essentially an entire group of interest. And the definition of this group of interest is basically up to you. If you're interested in all people on planet Earth, the global population is the global population. If you're interested in American adults, it's only the adults in the US. If you're interested in residents of New York, it's only New Yorkers. Sounds simple, but it's a perfect starting ground for distinguishing populations as samples or sample populations. You will hear me talk about sample populations and populations. This distinction is important because definitions differ and you name things differently when you talk about population and you name things differently when you talk about sample. Once we get to hypothesis testing, we will understand why I make this distinction. So a sample is essentially a subset of this group of interest, which in a perfect world would be perfectly generalizable to this population. So if you want to study the opinions of New Yorker about the humidity, and you pick out 10 people on the street here in front of Lexington Avenue, you may not get a generalizable sample because, I don't know, it's closer to the water, and it's not as humid, or whatever those factors could be. So generalizability actually becomes a very important topic when it comes to research, because most research, believe it or not, is not necessarily easily generalizable to the population. As an example, you know what? You study medications in samples of volunteers. And most randomized controlled trials that study these medications are essentially studied in a population that will end, in the end, is not the target group for that medication. It's unfortunately true because you only get a sample that is willing to participate in your study, and that is not necessarily a representative sample of that population where you actually employ that medication. So this is a huge topic in population health and study design. If you survey an entire group of interest, this is not a sample anymore, and it's not a sample survey or a sample study or a study in a sample, which is a subset of study. If you sample or you survey the entire group, so the entire population, you're looking at the census, which you know the US census, which is one of the largest endeavor worldwide. A single observation of your sample is called a record. Any questions to that? Simple, right? Where it's getting more interesting is when you actually study them, your population. And here you only study an outcome, which is deaths per 1,000 population. This is called a mortality rate. If you normalize the count, which is deaths, so you count 1,000 people die, 1,000 people die, it's a count. Right? If you standardize it for a certain amount of people in a population, it becomes a rate. It becomes a effector in time. So if you look at this descriptive statistic of mortality rate over time, what you see is essentially you see a lot of spikes that basically reflect here the outbreak of various diseases, mainly cholera, because back in the 19th century, they were not really entirely clear what caused infectious diarrhea. And there was kind of there was actually the birth of epidemiology in the 19th century by a physician called John Snow in London. So they actually found out by rooting back the increase of mortality rate due to diarrhea. They rooted it back to one particular source, a well that was contaminated. And they found out that actually only people that drank from this particular well were suffering from diarrhea and died because of that. So this is basically these spikes, these enormous spikes that are reflecting a certain kind of pattern, which is here in New York, the outbreak of cholera, are basically here being used for inferential statistics, because you draw an inference out of that dynamics, out of that spike. You know that there was something going on, and there was actually some problem that was being observed. So this is descriptive statistics that would just be showing the pattern. Drawing inferences from it becomes then inferential statistics. And this is basically what this slide shows, which is basically something that we hear often in the context of politics and political surveys, where you basically quantify approval rating of a particular candidate. Where you basically get an approval rating, negative approval, so you basically you disapprove, or you positively approve of the performance of the president, and you basically get a green. And when you get around this curve, you get a variability. This variability is based on the number of people that were surveyed and the variability between the responses. And we will talk about this when it comes to confidence intervals, because this is the margin of error, which you certainly have heard in the news when it came to political surveys. There's always a margin of error being stated in these surveys when they're being reported. And this is nothing else but a confidence interval, which we will talk about as the last topic before the midterms. And this is inferential statistics. So you're basically quantifying uncertainty. And you're basically comparing approval and disapproval against each other. And by knowing the variability, this margin of error, you can separate and quantify how separate are these curves and are they statistically significantly different. So that's inferential statistics. Here presented on time series. So this is employing these statistics, and I think these are just interesting examples from our day-to-day life, which we see on a daily basis. Right? You watch the news, you will be confronted with data like that. Okay, any questions? Good. All right. So this was enough of theory for today. We have 20 minutes left. So now I'm acting in my self-interest. So I want to now do a quick attendance because I want to associate names with faces. So please go with me on a roll call and forgive me if I mispronounce a name. So it's not my first language, so sometimes I pronounce things incorrectly. Okay, Noah Epicidon. Noah? No? Noah? No? Helen Ashkenazi. Right? Sheila Bakshi. Right? Rachel Berger. Right? Edina Bezalel. Kayla Kagan. Talia Dina. Fini El Kubi. No? Kira Urba. Hi. Abigail Goldberg. Hi. Sarah Grossman. Hi. Jaya Hill. Kaya Hill. Bruce Kaplowitz. Hi. Emily Kohenbusch. Hi. Yardena Lipson. Hi. Emma Matja. Hi. Maya Milul. Hi. Tiferet Mondrove. Mondrove?
Yeah,
Mondrove. Okay. Esther Mahon. Hi. Maxine Brafta. Hi. Maya Purov. Purov? Purov. Okay. Spare with me. I usually only mispronounce it once. Okay. Inbal Radai. Okay. Evie Rosenkrantz.
Yeah.
Right. Rachel Schmuel. Hi. Felicia Standing. What? Felicia? Hi. Felicia. Okay. Alison Warren. Hi. Hannah Wiesen. Hi. Ashley van Emmerongen. Hi. All right. Thank you. All right. So next, we're gonna go towards our Excel spreadsheet. Okay, who of you has absolutely no exposure to Excel? Yep. I hope to get you up to speed. Please watch that recording that I have posted, and I hope this is somewhat helpful. You have a functioning version of Excel on your computer, correct? Because that's key. So if you watch this this quick recording that I made, it kind of walks you through the basics. of Excel. But just quickly, I want to walk you through some of the aspects that are pertinent for the first classes. So we will do some analysis quite early in the game. And for now, I just want to bring a couple of basics to your attention. So first of all, you have here, you have a cursor and you select here individual cells. Once you select any cell, you get the cell location here on the left top. That's really important to keep in mind because this cell location corresponds with a certain value that essentially is corresponding with what you see here in the selector cell. So here E2 contains the value 105. So if I want to have now a function that refers to that value and looks exactly identically in its presentation, and I know this is terrible with the red marker. I'll try to remedy that for next time. So if you want to create a new entry that refers to an initial entry, you can do this with the equal sign. So now you're referring to D2 by pointing to that cell, transferring that value over to D2. And this is important because we will in the following do calculations with these values. So if you, who of you would know how you can calculate, how you can add 10% of the initial value to that number, to 105? How can you do that? Yeah? Equal, parentheses, D2. Okay. No. Okay, you could do it in various ways. If you want to do it your way, which I don't dislike your way. So it's D2 plus parentheses, or you can do D2, and now you first need the 10%, right? So D2, 10% of 105 is D2 divided by 10, because 105 is now 1, or 100%. You divide that by 10, you get to 10%. So this essentially is 10.5. If I have now D parentheses D2 divided by 10, and I add now plus D2, I get 115.5. So that's 110% of the initial value. But you're good thinking like that. Okay, so now you basically have different ways to do that. And this is important for the class in the following, because I will do that quite a bit. So if you want to separate, for example, two aliquots into two different percentages, so you have one value and you want to calculate 60% or 40% of that, you can do that by using proportions. And you calculate those proportions by essentially, if I wanted to calculate the initial value plus 10%, this is initial value plus 10%, can also be done by 110%. 110% as a proportion is 1.1. Make sense? And if I calculate now earnings, D2 multiplied by 1.1, I do exactly the same thing. If I want 60%, I do D2 multiplied by 0.6, that's 60%. Obviously, you need to write it correctly. Multiplied by 0.6 gives us 60% of the initial value. So that's important to keep in mind, please. And it's essentially the same if you do it with number fractions, but it's easier with proportions. So just keep this in mind that you can calculate percentages of an initial value quite easily by using, you want to have 4%, you do D2 multiplied by 0.04. This is 4%. Okay. It's just it's easier to approach it that way for what we will be doing moving forward. If you want to calculate now 4% for all these earnings here, you can do the same thing by having here the formula, and now essentially you go on your cell You see the border here is green for the selected cell. Here on the right, so you see here the cursor is being white and filled solid in white. If you go to the right lower corner, it turns into a solid black for us. If you double click the right lower corner, it will copy exactly that formula all the way down to the last entry that we recognize that there's nothing below that and will start. So it will complete the series with your formula. Reason why I'm telling you that is because we will need that. And this is quite important to know. Any questions to that? It's just propagating a formula. You basically just copy it indefinitely until you're at the end of the type data series. So this is now 4% of 150.92. Alternatively, what you also can do, and that's beautiful, because let's say you want to make a consecutive row of consequently increasing numbers. So you start with 1, you want to go to 2, next 3, and you want to complete that all the way down to your last entry. So you have now 1, 2, and 3. You want to complete it all the way through without any formulas, anything. You just again go, you select this series, consecutively increasing numbers. You go at the end, you go to the right lower corner, you click here, and it will complete this series all the way down. It's useful to know. Trust me, if you have 100 entries and you create a formula that kind of changes with each entry, it's like this is very powerful knowledge. Otherwise, you're gonna be busy for a long time. So these functions are very useful. Good. What else? You can then also do calculations. So you can calculate this, multiply by this, down, multiply this. It's a non-useful example, but so this essentially can be done. And what else would be useful? You can also you need to keep in mind the 4 different mathematical operators. So multiplication is shift and 8. So this is the asterisk. Division will be the slash, which is right under the question mark. And then plus and minus is kind of self-explaining. Division, same concept. Whatever formula you employ is essentially being employed to that cell that you employ it on. If you want to square the value, so let's say you want 1 squared, you basically use the head. The head is on top of 6, so shift 6 gives you the head. Everything coming after that is basically squaring it. If it's a 2, it squares it. If it's a 3, it's the cubic. 4, it's the power of 4. You can by that employ as many iterations to your formula. Okay. So 1 squared is 1. 4 squared is 4. 2 squared is 4. 3 squared is 9. 4 squared is 16. So you can do this all the way down. Simple, right? If you want to do the square root, to get it back to the initial value, you do SQRT of this squared value. Will essentially get it back to the initial value. So we will do a lot of these calculations. So just make sure you have tried it once. You know in broad strokes how it's being done. Any questions on that? Simple so far. Okay. What else would be relevant at this early stage? Okay. You can do various things. You can sort things. So if you select And we will do this when we come to frequency distribution. We will need to know how to do that. So we're sorting now our initial data set. So we have here name, age, year, earning. So we sold something, Teresa, Sarah, John, and Nicole. They sold something. They sold anything. They earned a little money from that, and they basically varied between the years. So you're looking here at a time series, essentially. The time series is multiple entries. That's how we would refer to it. You have here the common denominator, which is the name. And this basically, this name is identity. This name basically changes with the, logically with the age of the individual as per the year. So this makes it a time series because you're observing it all the time. So the year changes obviously because the individual gets older, the earnings change with what they earned from what sold in that respective year. So there are different ways to depict this data. If you would sort this data as you could do, you sort it by 2018. You may ask me, it's like, why do you put it into a small word fancy format? So one way to organize this is to basically put all the earnings for all these four individuals for year for 2018, year for 2019, year for 2020. So you can bring it in a wide format. This is actually how we call it. It's called wide format. If you have less distinguishing factors, less common denominators, here the name, and you have several columns that indicate the same earning for the same individual, this would be called a wide format. So this long format logically is called a long format. So this is how statisticians would refer to it. So a long format has usually a certain amount of redundancy, which here is found in the name. Mathematically respondent variable, which is age, because that's basically the current year minus the birth year. And then we have the earning, and this is the individual variable, the cycle variable that actually counts. So your focus is basically on earnings. And you can quantify these earnings in various ways. But you could, for example, you could summarize the earnings in a shape or form. For Teresa, you could say, okay, Teresa made 105 in 2018, and she made 115.5 in year 2019, and she made 113.19 in 2020. So this is the sum. So this is one way how to summarize the sum. Another way how to summarize the sum is with the sum function. So you put SUM. Sum is now D2, comma, and now you don't add a plus anymore. Now you make it a comma because the sum function wants the individual cells that you want to sum up separated by a comma rather than a plus. The plus is only if you use only the addition, the mathematical operator plus. If you use the function, you need to separate it by a comma. So you see now D2, comma, D6, comma, D10. Same value. Okay, simple. But what is now very nice from Excel, if you do again, so you select now both, or you can only select one, and you go on this right lower corner again, and you're just pulling this down, not double clicking it, but pulling it down. You essentially, you will change the formula now with every parallel shift that you're doing. So what was here, D2, D6, and D10 for Teresa is now D3, D7, and D11 for Sarah. And D4, D8, and D12 for Tom. So you basically, you shift your formula down, and by that you're summing up different cells. Makes life much easier. But you need to think it through what it actually did. Okay, let's go back. You have D2, D6, and D10 constitutes all the earning for the reason. D2, D6, D10. If you pull it down from the right lower corner, it will recognize that you wanted to do the same thing, just one lower, and it will lower the formula down. Make sense?
It only works because the names are arranged like that.
Yes. Correct. However, and this is a good point, because if you would do the following now, and you select your data series again, and you go on data and sort, and you're sorting now your earnings by name, which you can do, and you indicate it as headers, then basically it loses all the references. Because now suddenly it realizes that you resorted the thing, and now these formulas don't have up. So as you said, it is attaching this to a certain value. If you then start manipulating the data around, it will recognize, hey, this is not going anywhere what you originally intended, and it will give you missing reference. So that's when you need to go back. Whenever you need to go back, Command and C like zebra will do the job, or Control for the Windows user. All right. Any questions? Have a nice evening. See you on Wednesday. The recording is online, but tomorrow morning. You're welcome.